Right now you're falling. You don't feel it, you never have. The chair beneath you isn't holding you up so much as interrupting a fall that started the moment you existed and won't finish until something stops it. Gravity is the one thing you have never actually felt. That sounds wrong, doesn't it? Think about it, press your palm against a wall and you feel pressure. That's electromagnetism. Atoms refusing to share space. Every sensation you have ever had in your life came from something touching you, something pushing back. But gravity doesn't push. It pulls on every single atom in your body at exactly the same instant, evenly, all at once. There is nothing to push against. There is nothing to feel. Einstein called this the happiest thought of his life. And tonight, we're going to take it away from you. Not slowly, not gradually. We're going to switch it off at a specific second and watch what happens to you, to your house, to the ocean, to the sun, and to every atom that has ever existed. But first you need to understand what you're losing. In 1687, Isaac Newton published the Principia and did something nobody had done before. He said the apple and the moon obey the same rule: one falls. One doesn't, and they are doing exactly the same thing. The moon is falling. It has been falling for 4.5 billion years. It just keeps missing. That's what an orbit is, not floating. Falling sideways fast enough that the ground curves away underneath you at the same rate you drop. The astronauts on the space station aren't weightless because there's no gravity up there. Gravity up there is about 90% as strong as it is in your living room. They're weightless because they're falling, and so is everything around them. So nothing pushes back. Newton described gravity perfectly, he just couldn't measure how strong it actually was. That took a strange, brilliant, painfully shy man named Henry Cavendish. In 1798, working alone in a sealed shed behind his house, he hung 2 lead spheres from a thin wire and brought 2 much larger lead spheres nearby. Then he watched the wire twist. He was so worried about disturbing the experiment with his own body heat that he observed it through a telescope from outside the room. The twist was almost nothing, and from almost nothing he weighed the Earth. Here's the part that never stops being strange. Gravity is the weakest force in the universe, not one of the weak ones, the weakest. It is roughly 10 to the 36th power weaker than electromagnetism. Do you know what that means in practice? It means a magnet the size of your fingernail can pick up a paperclip off the floor. And in that moment, that tiny magnet is outmuscling the entire gravitational pull of a planet weighing 6 sextillion tons. Gravity loses that fight every time, and yet gravity built everything you have ever seen. So let's take it away. Second 1. Nothing happens. That's the first surprise. You don't get slammed into the ceiling. You don't get flung into orbit. The Earth is spinning, and at the equator the ground beneath you is moving at about 1,670 kilometers per hour. The instant gravity stops, you stop turning with it. You start moving in a perfectly straight line while the ground continues to curve away beneath you. But that separation is slow. You drift upward at roughly a 300th of the rate you'd normally fall. It's gentle, almost peaceful. Over the first minute you rise maybe 60 meters. Your coffee lifts out of the cup as a wobbling sphere. Dust that settled on your shelves years ago comes back up. Your house creaks and begins to breathe apart at the joints because every nail and beam in it was designed to resist a downward pull that no longer exists. You have about that long to appreciate it, because the air is leaving too. The atmosphere is not attached to the planet. It's a thin shell of gas that stays put for one reason only: weight. Remove that and it expands outward into the vacuum with nothing to stop it. Within minutes the pressure around you drops towards zero. Your lungs won't fail first, your blood will. Below a certain pressure, the water in your body boils at your own temperature. Meanwhile, the oceans are leaving. Every drop of water on Earth lifts away as enormous shimmering spheres, because in the absence of gravity, surface tension takes over and water pulls itself into balls. Waves that had been rolling for billions of years simply stop, hang, and rise. And under your feet, something far worse is starting. The center of the Earth is under about 360 gigapascals of pressure, 3.5 million times the pressure at sea level. That pressure exists for one reason. Gravity is crushing the planet inward and the rock is pushing back with exactly equal force. Remove one side of that equation and the other side wins. The Earth doesn't drift apart, the Earth unloads, the crust fractures as the mantle expands beneath it, continents split at the seams, the core, compressed for 4.5 billion years, finally gets to relax. Now look up. The Moon is traveling at about 1 kilometer per second. That velocity doesn't vanish, it just stops curving. The Moon leaves in a perfectly straight line and never comes back. And so do we. Earth orbits the Sun at 30 kilometers per second. From this second onward, we simply keep going, straight out, into the dark. Does the Sun even notice? The Sun stops existing. Fusion is not something a star chooses to do. Fusion happens because the crushing weight of the star's own mass squeezes its core to about 250 billion atmospheres and 15 million degrees, until hydrogen nuclei are forced close enough to overcome their own mutual repulsion. Take away the squeeze and fusion stops in an instant, not fades, stops. The star swells, cools, and dissolves outward into a vast cloud of gas that will never gather again. And the last sunlight ever produced is already on its way to you. It just needs 8 more minutes. Here's where it gets bigger than us. Every star in the sky formed because a cloud of hydrogen collapsed under its own gravity. Every planet formed because dust grains stuck together and pulled in more. Every galaxy, every solar system, every atom heavier than lithium was forged in a stellar core that only got hot enough because gravity crushed it there. You are made of carbon, oxygen, nitrogen, and iron. None of those elements existed at the start of the universe. All of them were manufactured under gravitational pressure inside stars that died before the Sun was born. Turn gravity off and the universe stays a thin, cold, evenly spread fog of hydrogen and helium forever. No structure, no chemistry, no one to notice. And we now know there's even more of it than we can see. In the 1970s, an astronomer named Vera Rubin, working with Kent Ford, measured how fast stars orbit at the outer edges of spiral galaxies. They should have been moving slowly, the way distant planets orbit the Sun slowly. They weren't, they were moving far too fast to be held in by the visible matter alone. Something invisible was pulling on them, something with mass we cannot see and still cannot identify. Fritz Zwicky had suspected it as early as 1933 and called it dark matter. Most of the gravity in the universe comes from something we have never touched, never captured, and cannot explain. So what is it actually? This is where Einstein rewrote everything. In 1915, he proposed that gravity is not a force at all. Mass and energy bend the shape of space and time around them, and objects moving through that bent shape are not being pulled off course. They're traveling in the straightest line available. You are not being held down. You are following the geometry of the universe as faithfully as it is possible to follow anything. In 2015, 100 years after Einstein wrote it down, the LIGO detectors caught 2 black holes colliding 1.3 billion light-years away. The ripple they sent through space stretched the detector by less than the width of a proton. Kip Thorne, Rainer Weiss, and Bari Barish shared the Nobel Prize for it 2 years later. We didn't just prove Einstein right, we heard the shape of space ringing like a bell. So here's the reframe. You've spent your entire life thinking of gravity as the thing that holds you down, the thing that makes you tired, the thing that breaks the glass when you drop it. It isn't holding you down, it's the reason there's a down. It's the reason there's a floor, a planet, a star, an element heavier than helium, and a body assembled out of all 3. Right now you're falling. Toward the center of the Earth, toward the Sun, toward the center of a galaxy that is itself falling toward something larger. You have never once felt it, you have never once escaped it, and it is the only reason there is a you here to fall at all.